Morning, everyone. As introduced, I'm Charles Brayne. I lead tax technology at EY in the UK. Harvey can introduce himself.
Hi, good morning, everyone. My name's Harvey Lewis. So I'm Chief Tax Data Scientist at EY.
So what are we going to cover this morning? I mean, we work in professional services. You might be sat there thinking, tax, this is quite interesting, isn't it, in the context of AI and how it could impact the world of work. We're going to talk you through some real practical examples of how we are implementing AI solutions within our tax business at EY. And with that in mind, talk about how we see these technologies impacting not just our world, but the world of professional services more generally, so people, businesses, and hopefully leave you with some sort of key takeaways and lessons that we've learned, because we've been on this journey over the last couple of years, about the impact it could have on the future world of work. I'm going to start with everyone will be familiar with the surveys conducted by the IMF and the World Bank about how the future of work is changing and the degree of automation that's going to impact all of our lives. There's a website that we sometimes play around with in my team called willrobotstakemyjob.com, which I'd encourage anyone to have a go with later. And if you type in tax, I've been working in tax for 18 years. If you type in the word tax, it comes up and says, are you a tax preparer? And you go, yeah, okay, that's reasonably close. And then it says, it's 99% certain that your job is going to be automated because of the rise of emerging technologies like AI. 99% certain. And if you were hoping that 1% might give you a little bit of wriggle room about what the future might hold, it then says, you are doomed. It's not great when you spend 18 years of your life trying to improve and perfect your professional insight and experience. Interestingly, for those of you who are in the tech profession, you might be thinking, well, that doesn't apply to me. You're actually quite right. If you type in computer and information systems managers, it says, you know what, you're going to be all right. There's projected growth in your profession, probably a 4% risk of automation. So I'm left looking at that and going, well, what is it that I do, and what is it that my people do that makes it so susceptible to being done in a different way using new technologies? I don't know how easy some of this is to read from the back, but if you think about what I do, I'm a tax professional who just happens to have worked in technology for a long, long time. And what is it that professionals do? Well, that they, at their best, it's about experience, it's about insight, it's about recognizing that sometimes there are bespoke challenges and situations that our clients find themselves in, and we need to find the perfect answer to that scenario and really help them get to the right outcome. That's when we're at our best. Actually, probably 80% of our time is spent looking at data, cleansing data, analyzing it, classifying it, categorizing it, creating tax computations, and to a certain extent, sharing knowledge, dealing with information retrieval, trying to capture all of the potential relevant facts to a situation and apply it to a client's particular set of facts. So whilst at our best, it's about experience, insight, and wisdom, 80% of the time, it's classification, categorization, labeling, data cleansing, the sorts of activities that technology, and particularly some of the AI technology that we've begun to adopt in our business, can do amazingly well. So we're paying high salaries to highly experienced people to do a series of low value added tasks, some of which they don't do incredibly well, and then we employ even more highly valuable people to check the work of the people who've been doing some of this low value added tasks because they don't do it tremendously well. That doesn't seem to be a fit model for the future. And I think that's why, whilst we'll get on to whether that 99% number is right, it's why certainly our profession is ripe for a real transformation and change. So with that, I'm going to hand over to Harvey, who's going to talk in more detail about exactly how we're using technology in our business.
Thanks, Charles. So I'm a technologist, right? So probably you're thinking, why on earth am I working in tax? Well, if you think about the common definition of artificial intelligence, which is that it is any technology capable of performing tasks which ordinarily you would consider to require human intelligence, then think about the range of activities that are susceptible to automation in tax, and you have all of the ingredients you need for a really very dynamic relationship between the processes that people perform and technology. So at EY, we use a wide range of artificial intelligence technologies, from computer vision all the way through to natural language processing. And our focus today really is on machine learning, which, as the name suggests, is the process by which machines learn to find patterns in a set of inputs by being given lots of examples together with their corresponding outputs. And we use machine learning in a number of different areas, particularly focusing on text classification for tax compliance and a wide range of other purposes. The advantage of machine learning is, of course, speed. So we're able to process great quantities of data really very rapidly. But also, the models that are generated through machine learning are entirely deterministic. And as Charles has already said, people can sometimes be inconsistent. They can make mistakes, they can get bored. And you know that a machine learning model, when it sees a set of inputs, will always provide you with the same output, irrespective of time of day. So I'm going to take you through 3 applications that we've been working on, but I'm going to focus a little bit on some of the lessons that we've learned as we've gone through before handing back to Charles so he can wrap things up. So when I first joined EY as a technologist, I was exposed to the sorts of practices and processes that our people performed. And I mean, I don't know what it's like in some of your organizations, but I've come to this conclusion that strategy and consulting are dominated by PowerPoint as the main tool of practice, and accountancy and tax is dominated by spreadsheets. Lots and lots of spreadsheets. And when we think about a process like tax compliance, which I didn't understand when I joined, it was explained to me that our tax professionals would take huge spreadsheets containing tens, if not hundreds of thousands of lines of transactional data, and they would take their training and their professional judgment, and they would look at those transactions, understanding the rules of the tax code, and then figure out what the tax treatment for each transaction should be, or indeed whether or not those transactions should fit into a particular type of spend category. And for a spreadsheet which contains tens of thousands of rows, and you're working line by line, that's a fairly exhausting and exhaustive process. It's really very time-consuming. So we wanted to be able to develop technology which could do that faster and more effectively. And the state of the art at the time, a couple of years ago, was rules. And you may all be familiar with rule-based systems and expert systems. The trouble with rules, particularly in this kind of a profession, is that they can become quite complex and very difficult to maintain. So over time, they start to lose their potency. And indeed, they can really only cover the simple cases, and you're still left to deal with the complex ones. So we wanted a more general purpose tool. And so the application we developed is what I would call a classic supervised machine learning technique. So we take a set of training data where all of our transactions have already been labeled by a tax professional, and we use those examples to build a model of how to translate from a description into a tax treatment or a category. And then we can take that model and we can apply it to new data as it comes in. So that's a fairly classic approach. And the key things we learned about that process when we applied it were that attention needs to be spent on the pre-processing of that data. You'd be amazed at the number of different ways people can describe the same thing. Or if you're having a bad day, you enter everything in uppercase. Or you use abbreviations and punctuation. So standardizing data before machine learning gets applied is really quite crucial. And the second thing that we learn about this classic approach is post-processing is also really very important. And one of the reasons for that is because when you apply machine learning, you can get quite a lot of information out from the process. So I'm sure you're all familiar with the probabilistic approach, which gives you a confidence that a particular transaction falls into a particular category. And many of you may interpret that confidence as whether or not the machine is right. And that is not how you should interpret confidence. Confidence is simply the likelihood that the patterns the machine sees in the data match the patterns it saw in the training data as it was learning. So if your training data is biased, if it is inconsistent and contains noise, that will be reflected in the confidence that's output. So one of the things that we learn when we apply classic machine learning like this in compliance-related areas, it's the same in safety-critical areas and autonomous vehicles, is you need to be able to explain how you got to the output. And when you need to explain how you get to the output, then your choice of algorithm becomes critical. In fact, it becomes more critical than absolute performance, because we need to be able to explain how a machine gets from input to output. So auditors and other people can have confidence, genuine confidence in the result. The other challenge with classic machine learning, as has already been described this morning, is data quality. So if you have poor quality data, then the models that you create will not be performant. They will not be accurate. You will not be able to use them. But how accurate do they have to be before they're usable? How do you quantify that in terms of data quality? So that's quite a hard question, and the only way you can answer that is if you put it in the context of the use case for which you want to use that data. So in other words, it's no good applying some generic data quality principles. You need to be very specific about how that data is going to be used and define your data quality metrics accordingly, which is what we've done with another application. So we are specifically measuring aspects of data quality that we know are going to be important when we want to apply our machine learning for tax determination. And that's really quite crucial because we define, therefore, a set of metrics that you probably wouldn't even have thought of. So a classic example would be in finance data. Finance teams regularly reverse out transactions on the ledger for accruals and other purposes. And they will label those transactions maybe in the same way that they label any other transaction. But as far as the machine is concerned, the description could be of anything. So it injects noise into the process. And I'm pretty certain that in generic data quality tools, you will not have a metric which is measuring reversals. So that's why you need to think quite carefully about the use case that you are applying your data to. And then the second most important thing about the quality is whether or not the model that is created by your machine learning algorithm is going to be fit for purpose when you give it new data. And that's a pretty tough question to answer. And it's why explanations start to become important. So there are simple things that you can do to understand the feature importance and relate that to your data. So in the case of text classification, for example, are you relying on spurious terms to enable your classification? Because if that's the case, then that model might not be good at generalizing, and that's a really important thing to consider. And the last application I want to talk through is something a bit different entirely. So the problem here is that a lot of people spend a lot of time Googling and searching for information which helps them do their job. And in the case of tax professionals, a lot of that effort is spent on monitoring for changes in tax legislation. So teams around the world, both within EY and a lot of our clients, spend their time trying to keep up to date with changes in the tax code, so changes in the rate of VAT, new taxes that are introduced, and indeed rumors about new policy changes in different tax jurisdictions. Again, it's really very time-consuming. And even systematic approaches that use people, where you try to incentivize people to monitor for these things, are difficult to implement, because if you work in one jurisdiction where changes are frequent and complex, and in another jurisdiction where changes are very infrequent, then it's difficult to incentivize the same activity because of that disparity between functions. So our hypothesis was that technology can help people do this job better. And the way we went about that is another very important lesson, which is you can run feasibility studies and proofs of concept that are really quite small in scale and tight in scope to understand whether or not the technology can help the professionals do their job. And indeed, when we built this application, we discovered that what was really important for this application was keeping the human in the loop. So if we're reading information from the World Wide Web or from a range of other sources, no one has labeled that for us. We can't take a set of training data and use it to build a model to classify. We have to do that on the fly, and the only way we can do that on the fly is if we've got someone who can interpret the documents that are being read. So we had to implement what's called an active machine learning process, and you may be familiar with this technique. An active process is different from a classic or passive supervised machine learning process in that the machine selects the samples using intelligence to give to the human to label. And in so doing, when we apply that process, we can read thousands of documents but only have to label a really small fraction of them to get good model utility. So some of the tests we've run, for example, we're only labeling 1 to 2% of the data, and we have a model which we can use. It's not perfect by any means, but it allows us to use that to categorize data that we read. And of course, in this process where you're recursively gathering content and labeling it, you are constantly improving. As you gather new content, you are providing more training examples, and therefore the model gets better and better. It might not be perhaps as fast as some of the classic techniques, but we can still churn through thousands of pages of text in just a couple of hours, which, if you're a tax professional working in this space, is a real help if it's going to take you a couple of weeks, for example, to read through lots of content. And this kind of approach, where we embed the person in the loop of the machine learning as it learns and predicts and improves over time, is something which is obviously generalizable to many other applications. So when you're thinking about applying machine learning, think about all the different approaches that you could apply and whether or not it is appropriate to include a person in the loop. So I'm going to hand back to Charles now just to wrap things up and take you through some of the finer lessons.
Thanks, Harvey. So for us in the UK, we have 1,300 people who help clients with their tax affairs. And we see this technology, and we've been on a journey for the last couple of years implementing AI solutions in our business to fundamentally transform how we help clients, and also helping clients implement this technology as well. What lessons have we learned? If I was to summarize it in one statement, it would be that our AI strategy is a people strategy, which might seem a little bit counterintuitive. Isn't it all about the technology? But we've invested a lot in bringing the right technologies into our organization so that we can create the tech solutions. But the questions it's raised for us, back to the 99%, is what's the impact on people, and where did people fit into all of this? As Harvey talked through, where we started was very much sort of classic pattern-based machine learning, passive models, effectively taking those training banks of data, getting that training data as perfect as it could possibly be, effectively train a model, use that model on fresh data, and then see what comes out. What kind of confidence scores do you get from that? But then recognizing very quickly, as Harvey was saying, that even in that model, there are certain barriers, there are certain inhibitors. The quality of the training data, even to begin with, means that your confidence score is going to be impaired. in the best circumstances. So then understanding, okay, there's a human review element to all of this, even using the AI technologies. But what does that human reviewer need to know? And looking at the banner headline to the left, explainable, practical, responsible. You have to create something that human reviewer can use, and you have to skill up that human reviewer so that he or she really understands what's coming out of this process. And that's very, very different to the way in which we used to work with our clients only 2 years ago. If we then start to look at where we've taken things over the last 6 to 12 months, which is, if you like, sort of second generation use of AI, it's really starting to rethink that whole process, that whole model, which is, we don't just build a technology, let the technology do its thing, and then have a human reviewer look at the output and start to try and make sense of it. It's actually embedding the role of the professional right at the heart of that technology-driven process. So in the examples of how we're starting to use AI now, as we move up the value curve in our business, it's recognizing that really we're having to put the professional at the heart of that training process. We are effectively nudging and changing and fixing the algorithms as we move forwards to make sure that what we deliver is something that can start to do the sorts of things that Harvey was talking about. Digest 5,000 websites overnight and work out, has anything happened in the world of tax globally that might be of interest for a particular client with a particular fact pattern, and actually display to them, well, what's going on. That's just not something that's possible to do, having a team of humans reading newspapers overnight. So recognizing that actually that human element is fundamental to the success of this process, but what are the skills and capabilities that person needs? It's not the skills and capabilities that I was trained on 15, 16 years ago. It's very, very different. So understanding how the AI is working, how do you detect bias, how do you understand when it's coming back with something that doesn't really make sense? What tweaks do you need to make in order to get the confidence scores up to a level where it all becomes usable? That's a very, very different skill set for a professional to have. So as we start to think about our 1,300 people, and that's just in the UK, and the skills and capabilities they're going to need in the future, we can't ignore this, we can't ignore these technologies, but what we're doing is starting to put processes together, which is about the technology, yes, but it's also about the skills and the capabilities and the talent development of our people, so they can start to use technologies like these as we move forward. So as I say, we have to have a strategy. We do have an AI strategy in our tax business, but it's very much a people-focused strategy. I suppose the last learnings are, we talk a lot about benefits, and certainly we have seen acceleration in terms of efficiency and the ability of the technology, as Harvey was saying, to read hundreds of thousands of lines of data in a matter of seconds. But actually there's a lot of effort that goes into setting up these models, setting up these tools, training them effectively, and there's still a lot of effort that goes into review, because in our world we can't afford to get things wrong. 90% isn't good enough. It needs to be 100%. If you're in audit, if you're in tax, you need to get to the right answer. So understanding, well, what's the combination of the human and the technology skills together is really important. We're also finding that we can fantastically improve quality. So by creating a process where the human and the technology sit side by side, hand in hand, some of the real benefits that we're starting to see flow through, it's not just efficiency, it's about quality, it's about accuracy, it's about the fact that we can honestly say to our clients, we have reviewed all 100,000 lines. We have looked line by line in a way that we simply wouldn't have done 2 years ago. We've looked at everything. We have digested 4,000 websites and worked out what's relevant to you, not just picked up on a few things here and there. So fundamentally, it's about quality. It is about efficiency, but it's also, and I'll keep coming back to this as we're transforming our business, it's about putting our people at the heart of how we use these technologies going forward. So with that, why don't I wrap up and hand it back? Thank you.